So this is the demo for part 6 of the procedure for Lab 1A, filtration. I've got some beakers. I don't have a Bunsen burner, you'll know why in a minute. I have fine white sand, which looks like this, and I've got sodium chloride, which looks, well, remarkably the same. They're nearly impossible to distinguish visually, and that's a problem because I've mixed the two of them together, and there's no way to separate these things, save filtration. So when we have either a liquid that has particles of contamination in it, or when we've got two substances together that have differing solubilities, we can separate them via filtration. So I'm going to be using filter paper today. This is like a coffee filter, remarkably. Similar material. The shape is a little different. And filter paper, really, if you feel it, it feels just like a coffee filter, but thicker. Don't confuse it with glazed paper. So if you pick up a piece of the glazed paper, some of them are the same shape, but the glazed paper is going to feel plasticky or waxy on one side. Don't try to use that to filter. That way lies disaster, heartache, and ruin. So I have my two substances here. Because I am going to be separating them based on solubility, I have to use something that one is soluble in and one is not. Salt, as you all know, is soluble in water. Your experience at the ocean would be very, very different if sodium chloride was not soluble in water. Sand is not soluble in water, and again, we'll go to the beach. The beach would be very different if sand dissolved in water easily. I can't really imagine what that would look like. So I've got my sand and salt mixture, and I'm going to add some distilled water, enough to dissolve these, and I'm going to stir this mixture to attempt to dissolve the salt. If you have all made solutions, if you have made Kool-Aid, you've made a solution, and if you haven't made Kool-Aid, you have homework. So when you're making Kool-Aid, one way to get the Kool-Aid and the sugar to dissolve is to stir it. Another is to add warmer water, but we're not going to do that because I've got the water I've got. Now, to get that dissolved salt that's in the water out of the water, I'm going to use my filter paper. So to fold a piece of filter paper to go into this funnel, I'm going to fold it first in half, and then I'm going to fold it in quarters. And then I'm going to open up 3 of those quarters. Now, do I have the right size? I do. One of the really important things is that this filter paper should never extend up over the funnel. It needs to sit down within the funnel completely. So this is a little bit, this is almost even too big, but it's okay. We can make it work for today. Before I put my filter paper in, I'm going to wet the funnel, and this is a wash bottle. I can use it to direct, a small stream of water over something like a funnel. That makes the filter paper sort of stick. And then I'm going to wet the filter paper, just with a little bit of distilled water. That will enable the soluble materials to travel through the filter paper more easily. So I've situated the funnel so that the neck of the funnel is down into the beaker, and it's touching the side of the beaker that I'm going to catch my filtrate in. What that allows is sort of a chain of water. The water molecules will actually pull one another down the side, and you get better flow through the filter. So I've stirred this, and I'm going to actually do what's called decantation, where I'm going to place the glass stir rod along the lip of the beaker, and I'm going to pour off sort of the first bit of water. So a lot of the sand should be left behind when I do this first step. It's going to drain fairly slowly, and I'm going to decant a little bit more, again using this technique so that it doesn't spill or splatter. You want to be very careful that you never overfill that filter, because if you do, then your insoluble material can run down the outside and end up in here. All that we want to have in here is our salt and our water, our soluble material and the solvent in which it is dissolved. That's called the filtrate. So I'll pour off a little bit more as it's draining. Okay, I've decanted about all that I can. So now I'm down to sort of like mud. Well, I have to get this solid material into the filter. And in order to do that, I'm going to have to add additional water. Now, I've got a problem here because I don't have a spare beaker, but that's okay. And I don't want to wait the entire time. That's mostly for purposes of the video. If you're doing this as a normal lab, you would just wait. And this is like watching, you've heard the expression like watching paint dry. Watching a filter drain might be actually worse than that, because you're just sort of standing here thinking, drain, drain? No, really, come on, drain. And it just keeps going. Oh well. I can decant a little more liquid off of here. That's about it. Now some of you probably have noticed that this glass stir rod has a funny end on it. This is actually called a rubber policeman. Weird name. It's basically a Chem Lab spatula. So if you've baked a cake, if you've made pancakes, if you've gotten material out of a bowl using a spatula to scrape it, that's what this rubber policeman is for. We sometimes forget to use them, which makes life much, much harder. So right now, I've got a little bit of space at the top of the filter. What I'm going to do is attempt to get the rest of the salt, or the rest of the sand, I'm sorry, out of the beaker. The wash bottle is fantastic because you can do this cool thing. You can shoot upwards, okay? So you can shoot upwards, and what that gives you is the ability to push material down into the filter. Now I gotta be careful, I'm almost at the top of the filter. The goal is that I get every single piece of material out of this beaker, because if I'm saving that sand, I want to make sure all that sand ends up in the filter. Now I'm going to tell you that I did not stir anywhere near long enough to dissolve all the salt. I'm quite sure that there's lots of salt that has not dissolved yet. But in an ideal world, if I was doing this for real, I would have used more water and I would have stirred more rapidly. And give that a slight tap. It's flowing pretty well. But I want to get all of this out of there. So again, if I add some water, and I can use that rubber policeman as a spatula, I can move that material down into the filter. So at this point, we're going to shortcut this a little bit for the sake of the video. I need to get the salt back. If I want to recover that salt, I'm going to have to evaporate it out of the water, because the difference between the salt and the water is their boiling point. That water will boil off at, don't you dare give it to me in Fahrenheit. This is science, we use Celsius, 100. 100 degrees Celsius is the boiling point of water. So if I get this mixture to 100 Celsius, the water will disappear. It will turn into a vapor. It will be lost out into the environment, and what will remain is the salt, because salt doesn't even melt until about 3,000 Celsius. It's got a very, very high melting point. To boil it off, to vaporize it, takes more energy than, well, it takes a lot of energy. So what I'm going to do, again, for the sake of the video, we're not going to let this drain fully. If we were doing this for real, if we were attempting to recover every single bit of salt that we had been given, I would never do this. But I'm just going to swap beakers, and we'll go ahead and let the rest of the filtrate run into there. Now, how do I recover this? Well, the lab tells you to use a Bunsen burner. I'm going to tell you that what a lot of chemistry teachers have found over the years, and I'm among them, is that using a hot plate is often a better option. So especially with masks on right now, I've got some concerns about lighting things on fire in front of your face when some of you have flammable things strapped to your faces. This is much safer. So when we can use a hot plate, we will. And this is not a special fancy hot plate. It's a pretty plain, simple, you know, just standard market hot plate. This is an evaporating dish. What you should notice about this is that it's relatively shallow for its width. And what that means is you've got a large surface area of your liquid that's going to be in contact with your, it's going to be in contact with the air, because that's where your particles are going to leave your filtrate. So evaporation, of course, is when water particles or any liquid particles go from a liquid to a vapor state from the surface. We're going to be doing two things. We're going to see some evaporation, but we're also going to be boiling this material. Boiling is different because there we have water molecules that are escaping the liquid phase from the bottom of the material. The shallower and wider this dish is, the faster our evaporation is. We have boiled off our filtrate in beakers, but you're really better off doing it in an evaporating dish. So I'm going to place my material into my evaporating dish. These evaporating dishes are a lab ceramic. They are very heat resistant. They are resistant to changes in temperature. That said, it doesn't mean you can't crack them. And if you had a lab ceramic dish crack, you would just treat it as though it was glass. It would go into broken glass disposal. You know, not an issue. So I said watching the filtrate evaporate was like watching paint dry. Well, this is like watching water boil, because that's in fact what you're doing. We're going to get this hot enough that you start to see some vapor come off. I would like to get it to the point where you get to see spatter, but I don't know that that's going to happen. One of the things, now again, for the sake of the video and for the sake of time, I cranked this hot plate up to high. If you were doing this yourself, you might want to crank it up to high to get it started, but then you want to dial back that heat. Because if it's too hot, what you will start to see is what's called spatter, not splatter, spatter, S-P-A-T-T-E-R. In spatter, you start to see chunks of whatever your dissolved solid is actually fly like little missile projectiles out of the evaporating dish. Now, in this case, you know, we're just kind of doing this to get the hang of filtration. If you were doing this in a situation where you were actually responsible for recovering all the material and not losing the material, that's a source of error. Because every one of those little flying missiles of salt is mass that you are losing. So you want to be real careful then when you are recovering a solid from a filtrate to not overheat it, because you'll get spatter and you'll lose material. Boy, you're taking your sweet time, aren't you? So I can see on the inside a little bit of, I can see bubbles. What are the bubbles? They're liquid water, they're molecules of water that are closely bound to other molecules of water. They're in a liquid phase that are getting enough energy to break free and go gaseous. But they're doing it from the bottom of the dish. Now, undoubtedly, because we're increasing the overall energy of this liquid, we've got particles at the top of the column that are also getting sort of the escape velocity, getting sufficient energy to break free. But once we start seeing significant bubbles in this, that's the point at which we would say it's boiling, and that's also the point at which we want to make sure the heat is well down. I'm going to stop this video. I'm going to pour off some of the liquid actually, and so I can show you what spatter looks like.